I'm very excited about showing this to you. Heiner's just got back from a trip to Melbourne where he witnessed the first workshop installation of the 48 volt architecture from Egon. And I want you to, the reaction is priceless of how simple this is, but how incredible the charge currents that this thing actually delivers to the battery.
3.5. No.
What are we getting there?
4,000.
4,000 watts.
44, 45.
It's still climbing, right?
Yeah.
5,500.
5,500.
Let's spread out 100 amps out of the alternator now.
Holy shit.
Hello and welcome to the Egon 48 volt adventure from Melbourne this time. We are at Unwind Designs where we are installing the first pre-production prototype of the 48 volt system into the Headspace Campus High Ace. I've brought everything with me on an airplane, actually fitted into a suitcase. Weight is about 18 kilograms for the whole system. And what we're going to do is put it into interior that's been designed here in Melbourne by Unwind Designs. They are usually doing things for troupies. As you can see in the background here, they've got some really nice troopy equipment with fold out beds, really nice long drawers, extremely cool hose reels as you can see here, and extremely high quality of workmanship. I have been a big fan and they have been big supporters of Egon ever since the get-go. This is the High Ace van from the guys from Headspace. So this is Ollie's product demonstrator with the very first roof conversion unit. And Karim is building a very nice interior. So you've got a enormous slide out kitchen here. That's a fridge, induction, everything built in. And what we're doing is fitting the Egon 48 volt architecture to Ollie's van. This is the first install of the first pre-production model of the Egon 48 volt hub. Our 48 volt hub is the central part of it, but then we have also got the alternator controller, the box that makes sure that everything integrates properly into the vehicle. We've got our DC converters here that will convert 48 to 12 volt. We've got harness for the wake speed regulator, some communication and temp senders and communication cables. And that is it. There's nothing more to this system. Everything else is the normal system as you know it anyway. And what we're going to do is, this is going to be installed into the Headspace High Ace van as part of our pre-production testing.
So Unwind Designs in Melbourne will be the first people on the east coast of Australia qualified to fit the 48 volt system, which will be rolled out in April 2026. Let me briefly explain why we feel it's a 180-degree flip. Normally you have an alternator charging a start battery and then the start battery via DC-DC charger which modulates the voltage so that the house batteries are happy and get a full charge, and then the house battery feeds the fridges, lights and inverter. Turn it around. Alternator, because this is possible with 48 volts. Alternator, house battery feeds start battery. It just keeps it charged and keeps current flowing to it while driving. But the house battery now is also charged by supplementary solar, for example. So in theory, the redundancy of the system is massive. If the alternator was to fail, it's a rare occurrence, but it happens occasionally, the solar charging the house battery would maintain the start battery and the vehicle would continue driving.
We have finally finished the installation of the board. It's gotten a bit heavy, but I mean, look how compact this is. This is about 40 by 60, if even. And what we've got on here is our wake speed controller, and the two DC-DC converters. So the wake speed controller, what that does is it can control the output of the alternator. It does that by measuring the current that's coming from the alternator. We can program this with a Bluetooth interface or directly with a USB interface. And the current coming out of it is measured on the DC hub 48 volt. And then this unit is smart enough to adjust the field current going to the alternator. And with that, we can vary the output of it. It can also drive proper charge cycles, just as if this unit would be a DC-DC charger. So we can set a charge voltage, we can set a maximum charge current. What it also does is it monitors the temperature of the alternator. So if the unit gets really hot, it can derate the alternator and keep it at a stable temperature, which is quite important because an alternator like the one that we're using here, 5 kilowatt alternator, produces a lot of internal heat, and this is a bit like a thermal fuse, so to speak, a smart thermal fuse. This unit has also got a CAN bus communication interface, so it integrates with the servo platform, and you can see on the screen how many watts are coming out of the alternator. We can also see the RPMs because we can monitor a tacho output signal, and that's one of the really key players in the 48 volt architecture from Egon. And then these two units here are DC-DC converters. What they do is they take a 48 volt input voltage and they put out 13.8 volt constant voltage up to 100 amps. So one of these units is being used to supply current to the exact same point where the 12 volt alternator used to feed into the vehicle. So this is basically now like a solid state alternator for your vehicle. And the other unit is there to supply the accessory circuit of the vehicle. So if you run fridges, lights, all that sort of stuff, you can take the output of the second unit. You also get a constant 13.8 volt output signal and up to 100 amps, and you can feed that into a fuse box. You can feed that into any switching system that you would like to work with. Any power distribution system you want to work with, you got 100 amps supplied to that. And the cool thing is, with the Egon 48 volt architecture, these units turn on when you turn accessories on, which means as soon as you turn accessories on your vehicle, you've got a 100 amp battery charger supplying your start battery circuit. And you've also got a 100 amp supply to your accessories, whatever you want to do with them. Another cool thing is, they also turn on through the relays on your Servo GX screen. So obviously you want to leave your accessories if you run your fridge. You want to leave that on, so you can go onto your touch screen and you just override the accessory signal and turn it on constantly from your Servo GX screen. And then your accessories run all the time. You can do the same thing with your start battery in case you want to have a constant 13.8 volt supply to your vehicle, which is quite handy if you want to leave your lights on around the campsite or do anything in regards to that. You can even connect a 3G, 4G modem to your Servo GX, and as soon as you got a telephone signal, you can turn your battery charger on from the other side of the world and maintain your start battery voltage. What other system can do that? On the other side of this board, we have got the Egon DC hub 48 volt, which is the centerpiece of the Egon 48 volt architecture. Everything connects to this.
I'm going to guess some of the questions you might be asking. Because 48 volts has got a bit of a bad press from unreliable systems, and that's because 48 volts is, in existing systems, very complicated. Our mission at Egon was to simplify it, and we have massively simplified it. So the next question is, well, cost. 48 volt systems are pricey. They're pricey because they're complex. Simplify it. We've done some preliminary costings. It is the same or less than an upper end 12 volt system.
We're 80% done with the electrical board, where everything is mounted to. It's actually a double-sided board, which is quite cool, super space saving. I'll show you what that looks like. So what we've done here is we've hooked up the battery connections. They're already going to a shunt and to a main fuse. We have actually gone a bit over the top. This is 2 BNS. 3 BNS would have actually been plenty for this. And then what we've got here is solar regulator directly connected to 48 volt. We've got the Safiri Starlight system, which I think is quite a cool system. I haven't tried it yet, but I'm quite excited to see how that goes. That is connected to the auxiliary 12 volt output. So this is our 12 volt distribution system. And then on here, we have got a Safiri 48 volt 1000 watt water heater, which is really cool for 48 volt systems. And then we've got DC-DC converter 1, DC-DC converter 2 with the feedback into the boards. And we've got our alternator regulator hooked up. And we've got the Servo GX hooked up, which is tucked underneath there. And then if you have a look underneath the board here, you can see that we have got our DC converters there, and the wake speed alternator regulator right there. One of the first things that needs to happen now is that the factory alternator will be deinstalled and the 48 volt alternator will be installed in its place as a direct replacement for the factory alternator. And there it is now. That is the installed alternator. As you can see, with the battery positive cable connected there. There's a temperature probe connected right here, so we can control the temperature of the alternator. And that is basically it. All the other little cables are just control cables that now need to be connected. The wiring will be done with 2 power cables and 1 multi-core control cable. So what we will have is we have 1 power cable that will transport 48 volt to the hub, and another one that will transport 12 volt back from the hub, and that will be connected to the cable that is now connecting the 12 volt alternator to the vehicle power supply system. This here is the finished under bonnet installation. What we've got here, this is our dummy regulator that tells the vehicle that it's still connected to a 12 volt alternator, and as soon as it gets a run signal from our alternator control cable that comes out of the 48 volt alternator, there's a tacho signal going in, and then it gives out a LIN bus signal to the ECU to tell it it's got a running alternator in it, and that switches the dash light off. In the Toyota Hi-Ace 48 volt installation, the ground for the feed to the vehicle and the ground feed for the alternator both go into one lug right here in the battery compartment. This is the main earth from the battery to the vehicle, and both negatives are being connected here, while both positives, like you saw before, are being connected under the bonnet. And then we still need an accessory feed, which we can quite easily get right here from this little fuse box, because this has got an accessory feed, fused accessory feed to it, and we use that to switch the whole installation on and off.
And that one goes to the battery 12 volt here.
Correct. That feeds back in to where the 12 volt alternator used to feed in.
Yes.
It's important to remember here that Heine went to Unwind Designs to witness their installation, so he could pick up any pain points, any confusions with the installation, so that as we create our support network, our videos, our instruction booklets, we understand the mindset of workshops, because that's the whole point of this. If you simplify it, workshops will find it quick and easy to install, and it brings the price down.
I think it's very simple, apart from the fact that I don't actually know what cable goes where, because you're the instruction manual.
Yeah, that is so true. Instruction
but
manual is
in
definitely
terms
necessary.
of wiring it up, it's as simple as any other, or as complicated as any other system. It's not. I wouldn't say it's easier or harder than something else.
That's 53 volts there. That's the battery. That's the alternator. That is looking really good, Karim.
We should now be charging the start battery. Yep. And the starlight has turned on as well. Wicked. Okay, we are starting the engine for the first time now. I want to see Karim's face when it's really pumping out some amps. So let's see how this goes.
We got we got power already. Yeah. Three and a half. No.
What are we getting there?
4,000.
4,000 watts.
44, 45.
It's still climbing, right?
Yeah.
What's that? Like 5,500?
5,500.
That's flat out 100 amps out of the alternator now.
Holy shit.
Changes a bit when you have it in idle.
Even at idle, you're getting 1,100 watts.
Yeah, and now look at high idle. So we're now at...
That's 3,000.
That's 1,200 RPM.
That's 4,000.
I know, 4,000 watts at 1,200 RPM, right?
Is that just the alternator that's that powerful?
It works!
We can get it on.
I've never seen it at 5,500.
That was...
Now I'll have a beer. I have now found a real issue with this 48 volt system that we've got. Quite frustrating because every time I want to test things, I want to test them thoroughly over a long period of time. Even this big 200 amp hour battery, it's just full like that. And I'm trying to run things flat out, and then I have to come up with quite inventive ways of discharging the battery again. At the moment I've got a vacuum cleaner and a heat gun running at the same time, plus I've got all the things in the vehicle on to discharge directly. So we're pulling about 2.5 kilowatts, that's the heat gun, on and off into the AC loads, and about 1,000 watts into the DC loads. But that combined is only about 50-60 amps out of the battery. Everything's been running flat out for almost, I think, half an hour now, and the battery's only at 90%. If I turn the engine back on now, I get about 10 minutes of testing if I'm lucky, and battery's full again. But what a problem to have, right?
So what does this massive charge rate actually mean? So if you're pulling a trailer or a caravan, its advantages are even bigger, because right now, attaching a trailer, we're using an Anderson. At best, with a 12 volt system, you might, if you're lucky, get a 50 amp charge to your trailer batteries. Okay, as I say, if you're lucky, if you've got a really heavy duty system, really thick cables. With this system, you run a 48 volt cable, you don't have the voltage drops, to the caravan or trailer. You can use an MPPT controller, you can use your solar controller, or a separate 48 to 12 converter in the trailer. You'll easily hit a 100 amp charge. Easily.
The engine is now running at a comfortable 1,300, 1,400 RPM, and look what we're getting. That's with the engine at high idle. We're getting 4 kilowatts of charge into the battery. This is the controls for the alternator. We are at 100% utilization. We can monitor the temperature, so just in case the alternator gets too hot, it will derate the field. We could do a maximum of 100 amps, that would be allowed from the alternator now. We're doing 74 amps directly out of the alternator. Our target voltage is 56.4. We are only at 54.2 at the moment. It's really hard to keep the RPMs consistent. That's why we are looking at putting a throttle controller in from iThrottle, because they have got something that is called a winch mode. Means they can control not just a throttle response, but they can control a certain RPM from the engine. So means we can just set the RPMs at 1500, 1400, and the throttle controller will just automatically keep it there, which is really cool for these situations where you just want to charge while you're stationary. What I'm doing at the moment is a little bit less technical. I'll show you what that looks like.